Hello everyone, this is my submission for the hackathon. This is my Linux IR agent, something that's still a work in progress, but this is my submission for it. I think it has a lot of, it's really promising. And here's what it does. It has a web GUI for newcomers, but you can use the terminal. And it treats every evidence as read-only. It has self-correction. It has an orchestrator that kind of decides what's going on. It has an auditor that makes sense that makes sense out of any claims other agents do, and then it has an IR expert that goes through them and maps them to any local or non-local threat intel that you might have. And finally, it makes a report based on 12 mandatory IR questions and answers. So it also makes an attacker profile and so on, but I want to make sure this presentation doesn't take too long. But yeah, here's the repo for it. As you can see, here's the diagram. And you can see that there's an untrusted zone and a trust zone. The untrusted is pretty much anything AI, and then it passes the trust boundary, which is not an AI guardrail. It's actually a tool, a Python function called dispatch that is the choke point. And dispatch calls something called the enforcer, and the enforcer kind of checks against what is being done, and it decides if it's good or not. And then we have the trusted part of it, as you can see here. Here's some examples of it. Here's the gateway, for example, the gateway where you can look at the dispatch code if you want. Here is share.py, this is something that all agents have as a not guardrail, but this is just kind of like scoping them a little more, because the guardrail, again, it's this Python function, and I did it that way so it can be exploited through the AI. What else? This is the constraint. This is like the mechanism that detects what can happen, what cannot. And for example, here binaries that should be treated as read-only. And here we see and some of the blocked binaries are like dd, change, chmod, and so on. So it kind of like evaluates based on context and then what's being run as well. Um, and this is a spoliation test, which is a test that on 10 delivery attacks, but we have that, so we test against live information too. Um, so the model tries all of those calls. And of course, what's out of scope doesn't count, but what is part of the scope does count, and that's just kind of helps you understand what that is actually being blocked, and it's self-learning. But yeah, let's go to the terminal demo, which is what people want to see. All right, so for this portion, we're on the terminal, like I was saying. You gotta, I mean, there's instructions to how to set it up, and I highly encourage you to do that. This is just 5 minute overall. I highly encourage you to do it yourself. But if you do, we run Python and Linux IR and Rails spoliation test, and it should show there the 10 attack attempts, and you see 10 logged, and that's the read-only promise demonstrated but not claimed. But this is just a demonstration of it, and now to see it in action, which just do uv run Python region Linux IR, analyze case from cases, and we're going to do a sample case. And it's going to be offline. Why? Because I'm not going to use my Claude for it. It's going to take a million years. So as you can see, there's a little bit of it. This is just a simulate to kind of just demonstrate. Specialists investigate, auditor reviews, confirms findings and reports on the report, the analysis to disk, the analysis of the log, the compromise answers, which are 12 curated questions just to understand a little more of what are we talking about, that you can also see there. Recommendations on what to do next, attacker profile, timeline, the narrative, kind of like the story behind it. And we also have this spoliation attempts and the self-learning parts of it. But here's another one. Let me, yeah, just very quick. This is the same that we were talking about, but not offline. This was actually run against 1.2 gigabytes of multi-host Linux logs. It is called 4557 because I actually got those logs from the instructor from that class. So thank you, Taz. Appreciate it. And as you can see here, we see what's generated output from the agent, which is the audit, the corrections, and the vault. And we see the agent messages, spoliation attempts, tool calls. We check the self-learning log as well. And the final report, which is like, it builds a persona for what we're seeing, and we have a report based on that. And here you can just see the self-learning part of it, which is not which was run live, and this is just the records of it. So you're more than welcome to read it as well too. Um, yeah, I think that should be it. It's read-only by construction, it's self-correcting, and you should totally check it against your own type of data. Yeah, thank you very much.